Hello everyone, this is my daughter Bentley. She's going to help me talk about truncated cones and pyramids. So we have a Play-Doh cone, kind of. Now what truncated means is basically means we cut it off. So here Bentley, can you take your scissors and cut? There we go, see? So if we cut, now this part got flattened a little, but basically we have two cones now. We have a little tiny cone here, and we have a cone with the top chopped off. So this is the truncated cone right here. Okay. Same can be done with pyramids. Okay. I tried to make a square pyramid, but did the best I could. All right. So Bentley, can you cut off the top here? Awesome. All right. And again, this would be the truncated pyramid, so it's basically a pyramid with the top cut off, so we have a teeny tiny pyramid right here. So can you say truncated cone?
Truncated cone.
Can you say truncated pyramid?
Truncated pyramid.
Alright, so this is Geometry, Unit 10, Lesson 11, Volume of Truncated Cones and Pyramids. Hey, who's this?
Swan.
Stop looking at me, Swan. Alright, so this is Lesson 11 from Unit 10 on Volume of Truncated Cones. I think there's a pyramid on here too. Alright, so number one, set up and solve an equation to find the value of x in the x shown in the diagram. So over here, here's x. So basically it's kind of a cross section of this full cone. Right, so this is the part that was removed. Right, we want to find this x, because essentially that's going to give us the height of the cone that was removed. So it tells us that this is 20, so the whole thing is whatever this is plus 20, so x plus 20. 6 here, 4.5 here. So what we actually have is a triangle and then another triangle that's going to be similar to that. So we can use proportions to find this x, which would then give us this total height. So what I'm going to do is line equals sign line. Alright, I'm going to do 6 to 4.5. 6 to 4.5. It's not the only way to start it, but that's how I'm going to do it. So I'm talking about this large triangle to the smaller triangle down here. So if we wanted to, so let's do this one in pink. Alright, so that's the small one. So 6 to 4.5. So then the longest side of this triangle is x plus 20, and then the shorter side, so the corresponding side of the pink triangle, is x. Alright, so maybe 4 points, so maybe if we do that. Alright, now to solve this, I'm going to cross multiply. Alright, so 4.5 times x plus 20 is equal to 6x. So notice I put the x plus 20 in parentheses. We've got to distribute. So we'd get 4.5x plus 4.5 times 20, I believe, is 90, equals 6x. If I subtract 4.5 from both sides, I get 90 equals 1.5x, or 1.5x equals 90. If we divide by 1.5, let's see here, so 90 divided by 1.5 is 60. So that means this portion here is 60. Now I know it doesn't look to scale, we can't go by what it looks like, we gotta go by what the numbers are telling us. So that means that this entire height is 60 plus 20, which is 80. Okay, x plus 20. So right now we know that if it were a full cone, the radius up top or at the base would be 6 and the height would be 80. So if we want to find the volume of the cup to the nearest cubic centimeter, we're going to take the volume of the large cone, okay, and that's 1/3 pi r squared h. Alright, so that's the formula for the volume of a cone. So this one, the large one, would have 1/3 pi times the radius 6 squared times the height 80. Okay, and then the smaller cone, so volume of the small, would be, again, 1/3 pi r squared h. But this time, 1/3 times pi times the radius here would be 4.5 squared, and this height would be 60. Alright, and then let's type those in. So we get 1/3 times pi times 6 squared times 80. So that has a volume of about 3016. Alright, and the volume of the small one, so I'm going to just kind of copy that and change the 6 to 4.5. So 1,696. 1,696. So the total volume would be these two, the large one minus the small one. So 3016 minus 1696, 1,320 cubic centimeters. Okay, hopefully I rounded right and everything. So, all right, the next one, kind of the same idea. A plastic vessel has the shape of a truncated cone as shown. So kind of the same thing. They want us to, so cubic centimeter is the same as a milliliter. What is the volume? So to the nearest millimeter, show the work you need to find the answer. So I think what we need to do is fill this in. We've got this part's 10. All right, this part we don't know. If this whole thing is 6.4, then from here to here would be half of that, 3.2. If this is 4.8, then half of that would be 2.4. So we need to set up and solve a proportion to get this x, which would then allow us to get this height. So proportion, line equals sign line. We've got same thing as above. We're going to do similar triangles. So 3.2 to 2.4. So I'll use the same colors. So green, 3.2, to pink, 2.4. Alright, and then green would be, so this whole thing would be x plus 10. So x plus 10. And then this would just be x. So to solve this, cross multiply, 2.4 times x plus 10 is equal to 3.2x. 2.4x plus 24 equals 3.2x. I'm going to subtract 2.4x. I get 24 is equal to 0.8x. So if I divide 24 by 0.8, we get 30. So that tells us that this part right down here is 30. Again, you got to go by the numbers, can't go by what it looks like. So the whole thing is this 30 plus this 10, so 40. Alright, so we still don't know the volume. We know how to get it now. We're going to take the volume of the large, which is 1/3 times pi times the radius, 3.2 squared, times the height, 40. So 3.2, the radius, 40. So I'm using those two measurements. And then I'm going to do the volume of the small, 1/3 pi, this time using 2.4 for the radius, squared, times its height, which is 30. I'm going to type all of this into my calculator all at once. So, not second, we're going to do math. Fraction. 1/3 times pi times 3.2 squared times 40 minus 1/3 times pi times 2.4 squared times 30. So the volume is about 248 milliliters. So it would just say to the nearest milliliter. Yeah, 248 milliliters. All right. And then down here it says there are 16 liquid measuring cups in a gallon. If a gallon contains 3.785 milliliters, is the vessel, is that three? It might be 3,000. It's got to be 3,000. Mine got cut off a little. Is the vessel above, more or less than a liquid measuring cup? All right, so 16 liquid measuring cups in a gallon. So 16 cups in 1 gallon. So what I would maybe do is first figure out, well, how many gallons do we have? So we don't even have a full gallon. So 3,785 milliliters in 1 gallon. And we have 248 milliliters. So how many gallons is that? So cross multiply. I'm going to have to do 248 divided by 3,785. So about 0.066 gallons. So 16 cups is 1 gallon. So how many cups is 0.66 gallons? So instead of cross multiplying, well, I guess it doesn't matter what you do, but essentially you're going to do 16 times that answer. And 1.05. So the question is the vessel above, more or less than the liquid measuring cup? So 1.05 cups is just a tad over a measuring cup. It's 5/100ths of a cup over. So it's about a cup. Now we know that. So is it? Yeah. Yes. I guess answering the question. All right. Next one I think is the pyramid. All right. So basically goes through same manner. Cone will be similar right triangles. A monument has the shape of a truncated pyramid shown below. Square base, square top. Its height is 5. So I'm assuming this is 5. We'd have to figure this part out. So this part is x plus 5. So I'm using colors. We've got x plus 5. We're going to know this, I believe. We're going to find this part by using this part. Height 5. X plus 5. Okay. So the extended version. So what we have here, if you see here, it says that this is 2 feet. Actually, I guess the whole thing is 2 feet. So that would make this 1 foot. But we're actually going to use, well, actually, so if the whole bottom is 3 feet and this is half of that, then this would be 1.5 feet. So we got to use that to find x so that we can find all this stuff so that we can then find the volume. All right. Here we go. So first we're going to do a proportion so we can find x and then x plus 5. So line equals sine line. We're going to do 1.5 to 1. And then we're going to do x plus 5 is 2x. Alright, so if we cross multiply, we get 1.5x is equal to 1 times that, so it's just x plus 5. So subtracting a full x gives us 0.5x equals 5. If we then figure that out, it should be 10. So that tells us that x is 10, so the whole thing is 15, because it's x plus 5. Alright, so we have the large pyramid. So pyramids, it's 1/3 the area of the base times the height. So in this case, the area of the base is the area of the square. So for the large one, it's the 3 by 3 at the bottom. So 9 times the total height, which we found to be 15. the volume of the small one that was removed would be 1/3 the area of its base, so the 2 by 2, which is 4, times its height, which is 10. So, if we do both of those, and I'm going to type them both into the calculator at the same time, because I'm going to subtract this from this, so 1/3. 1/3, you can't see that, times 9, times 15, minus 1/3, 1/3, times 4, times 10, 95/3, so let's change that to a decimal. Decimal, sorry. 31.6 repeating, so it says to the nearest tenth of a cubic foot, so the volume in total would be 31.7 cubic feet. If the monument is made from marble that weighs 170 pounds per cubic foot, so proportion 170 pounds per 1 cubic foot, and we have 31.7 cubic feet, I'm sure they're going to ask how many tons is this monument to the nearest tenth of a ton? So we're going to, how many pounds? So 170 times 31.7, 5,389 pounds. Now we want tons. Now if you don't remember, there's 2,000 pounds in 1 ton, and we have 5,389 pounds. So how many tons? So I'm going to essentially take, if we cross multiply, you get 2,000 times something equals 5,389. We're going to basically have to take 5,389 and divide by 2,000. 2.6945, and it says to the nearest tenth, I believe, of a ton. So 2.7 tons. Alright, now the last one, I believe, asks us to kind of take something from home and do it. Maybe I'll do in a different video this cup. It's a Rudolph cup. Right? See what the volume is. It's kind of like a truncated cone. Anyway, so maybe in a different video I'll do that. Or, if you want to try it on your own, this one kind of has multiple answers, but if you want a guide, you can take a look at the first two. You have to find the volume of the largest cone as if it were whole. Use similar triangles to find the missing pieces. So maybe that's for another video. Hopefully everyone's doing all right. And that's it for now. Hopefully this is a help.